Okay, good evening, welcome to
FunMath number 153.
FunMath number 153. This is another awesome problem from that teacher, FunMath, that we follow on Twitter, and she's got some pretty cool problems, right?
Yeah.
This one is a sort of a geometry problem, but we're going to look at the number pattern instead of the geometry, because we've done a lot of geometry problems lately, and what's the problem with us doing geometry problems?
We don't know geometry that
Right,
much.
we haven't studied geometry yet, so if you haven't studied geometry, it doesn't make sense to do geometry problems every single night, right? Because pretty soon you're going to accidentally learn geometry.
Yeah.
Yeah, we wouldn't want to do that. But anyway, so it's a cool problem. You start with a circle, and then you take away two middle circles, then you add back the middle of those circles, and you take away the middle of the circles you just added back, and you keep doing that pattern forever. And you get something that kind of looks like a... Do you remember the word when we do these repeated patterns like this?
No.
Begins with an F and rhymes with pterodactyl.
Fractal.
Fractal. So you get something that kind of looks like a fractal. Anyway, the area starts at 1 because you take some stuff away, it goes down to 1/2. Now you put some stuff back, it goes up to 3/4. Then you take some stuff away, it goes down to 5/8 and keeps bouncing back and forth. And it makes a really neat pattern. And we saw the first 5 numbers on a picture she put on Twitter, and we figured out these next ones, right?
Yeah.
Okay. And we found that pattern. I helped you a little bit with that. But these numbers, the top, the numerators, 1, 1, 3, 5, 11, 21, 43, 85, have their own really cool pattern, and these are called the Jacobstall numbers. Oh, actually, I forgot their name, but you can look them up. This pattern, I'd never seen them before today. I thought it was really cool, and so we're going to try to see if we can figure out the pattern for these numbers. Okay?
Yeah.
But backing up first, do you see? Can you tell me if you see or have any hint on what these fractions might be converging to? They might be getting closer and closer to something, and that'll help us look for a pattern here. Do you see anything in these numbers? Like, you see, and I know this is kind of a hard question, I'm going to have to lead you there, but 21 over 32, does that look like a number of another fraction? Do you see that that might be anything simple?
Well, 2/3 seems...
Kind of looks like 2/3, which would be, wait, which would be 20 over 30, right?
Yeah.
Okay, what about 43 over 64?
40 over 60.
Okay, 40 over 60, what's that?
4/6, or 2/3.
Okay, what about the next one? 85 over
Yeah, it
128?
seems like it's getting close to 2/3.
Seems like it's getting close to 2/3.
It also starts at 1, goes down, up, down, up, down, up, down.
Yeah, it kind of wiggles back and forth, but it seems like it's sort of wiggling in to be 2/3, right?
Yeah.
Okay, so that gives a really cool idea if we look at these numbers, and it's a little bit hard to see what this pattern is, right?
No.
Watch this. What if we multiply all these numbers by 3? Because it's converging to 2/3. So if we multiply by 3, we sort of get rid of the fraction.
Yeah.
Okay, let's see what happens. I get 3, 3, 9, 15, 33, 63. What's this one when I multiply by 3?
129.
129. And what's 85 times 3?
It's 255.
255. Now, this pattern is a little easier to see than the pattern before you multiplied by 3. Do you notice anything similar about these numbers? And sometimes it's easier to start out here than it is down here. Do you notice anything interesting about those numbers, especially the ones at the end?
They're getting big fast.
They are getting big fast.
What was the last digit pattern? 3395. 3395.
Oh, that's interesting. Okay, very good. I actually didn't notice that myself. Do you notice anything interesting about the whole numbers over here? 255, 129, 63, 33.
It almost looks like they're doubling.
They are. It does almost look like they're doubling.
Except for the 2 at the front.
Except for the 2 at the front. These numbers look familiar at all? They look like they're close to any numbers?
Squares. I mean cubes.
What numbers do you think this is close to? That's a number you see.
256.
What about this?
128.
What about this?
64.
What about this?
30.
64.
32. 12. 16.
So what's special about the numbers 256, 128, 64, 32, 16?
They're all some sort of exponent.
Of what number?
2.
2. And how close are these to powers of 2?
They're all 1 away.
They're all 1 away. This is plus 1 to get to a power of 2, minus 1 to get to a power of 2, plus 1 to get to a power of 2, minus 1 to get to a power of 2, plus 1 to get to a power of 2, minus 1 to get to a power of 2. Hey, 3 plus 1 gets me a power of 2, and 3 minus 1 gets me to a power of 2. Very, very close to powers of 2. Very cool pattern here in these numbers. And you would not believe all the different ways these numbers show up. Super cool. They're even kind of a little bit related to the Fibonacci numbers, believe it or not. Pretty neat, right?
They're still the same 1, 1.
So this pattern finding is really important in math. And this one of just taking pieces of circles and taking them out and putting them back together, really cool. Really cool. This is stuff that mathematicians have a lot of fun studying. Pretty neat problem?
Yeah.
All right. Good job, sweetie pie. Good job.